The objective of this lesson is that I can find the arc length of a circle. So let's first talk about what arc length is. So it is the measure of a portion of a circle of the perimeter of a circle. So here we have this angle theta, and we're interested in determining what the arc length is of this portion of our circle. And then we are given, this is our radius. And so technically this S stands for the arc length. And then theta is our angle measure. So the way I like to think about this is the circumference of a circle is the perimeter of a circle. And the formula for that is 2 pi r. So the circumference formula is 2 pi r. And then the arc length formula, which is really S here, it's this central angle theta. Now the angle around the entire circle, so like this part here, this is theta. But like if we had an angle that was around the whole circle, this would be 360 degrees. So we can actually take theta, I'm just gonna backspace all that, and we can have theta over 360 degrees times 2 pi r. And then the 2 and the 360 degrees would divide out. The 360 degrees would divide by the 2. And we'd have theta over 180 degrees times pi r. So this is what I would say is the formula for the arc length if theta is in degrees. But we know that with trig we use radians a lot of times. So we know that pi radians equals 180 degrees. So we can actually simplify this formula more, because we can actually think of this pi as 180 degrees and then times r. And so our actual formula for arc length is r times theta, given that theta is in radians. So let's go ahead and use this formula a few times. Okay, so here we're going to figure out what the arc length is using this formula. So it's S is r times theta, where r is the radius, and then theta is the central angle. So for number 1, we have that r is 3 and theta is 5 pi over 6. So our arc length, and just to visualize this, you could actually like really draw it. If you had a circle, so one full rotation is 360 degrees, which is 2 pi. So half a rotation would be 180 degrees, which is pi. So we know that pi is the same as 6 pi over 6. So I know that this angle will be somewhere in this quadrant. So I just want to emphasize that first. And then it would be like this circle, and then this is a radius 3. So that's the way it would look visually. I'm not going to do that again, but I just want to write that for now. So we would do 3, because that's our radius, going back to our formula, times 5 pi over 6. And then the 3 will cancel with the 6, and this will be 5 pi over 2. All right, we're going to go a little bit quicker now. So we have pi over 4 as theta times 14.5. So we do 14.5 times pi over 4. So that's going to be 14.5 over 4 times pi. And then we can rewrite that as 3.625 pi. On to number 3. So we have S is going to be 0.5. And then we're going to multiply that by 3 pi over 2. So this 0.5 is really 1/2. So it's 1/2 times 3 pi over 2. So that's 3 pi over 4. Number 4, we're going to have S is 6.2 times 2 pi. So 6.2 times 2 is going to be 12.4. So it's 12.4 pi. So here we're given angles in degrees. So what I'm going to do is just really convert them to radians. So we are going to do 15 degrees over 180 degrees times pi. Remember, it's you take the angle and then you multiply it by pi over 180. And essentially you have degrees in the numerator and denominator, so you're going to end up doing 15 over 180 times pi, which ends up being just 1/12 over 1 over 12 times pi, so we just write that as pi over 12. So then we can find the arc length. It's 8.4 times pi over 12. So we're going to do 8.4 over 12 times pi. And I just put it in the calculator, but I get 7 over 10 pi. All right, 330 degrees. So we're going to convert that to radians again. So we multiply it by pi over 180 degrees. We're then going to have 11 pi over 6. And then we can figure our arc length. We do S is 10.5 times 11 pi over 6. So I'm going to have 19.25 pi. All right, so then for the next one, we're going to first convert 120 degrees to radians. So we're going to do pi over 180 again. That's going to end up being 3 pi over 4. And then we're going to have, 2 pi over 3. So then we do 1.8 times 2 pi over 3. And that's 3.6 over 3. Oh, I'm sorry. I made another mistake. 5.4 over 3. Hold on, I'm sorry. I did 1.8. Sorry. Okay, it was 3.6. I'm sorry. I don't know why I just did that again. All right, 3.6 over 3 times pi, which is going to be 1.2 pi. There we go. And then for the next one, we are going to have 135 degrees. We have to convert that to radians. So we do pi over 180. And I end up getting 3 pi over 4 when I simplify that. So then I have that S is going to be 3 pi over 4 times 25, which is 75 pi over 4. You should be able to determine the arc length of a given arc in a circle now.